Hello dear students, today the topic of our discussion will be the pressure belts. See, yesterday we learnt about winds and their direction and their intensity. Now what are these pressure belts? These pressure belts are integral phenomena that dictate the wind system of the world. Without these pressure belts, there would be no permanent wind systems on the planet of the Earth. Now, these pressure belts dictate the climatic conditions of the Earth. In the sense, they create the flow of winds from one region to another region, causing the climatic effects as well as rainfall. Now, how are these pressure belts formed? There is two major ways in which pressure belts are formed. The first one is thermal. The pressure belts that are formed due to temperature. Now, a basic idea of wind movement. So, this is a piece of land. Due to excess sunlight in the day, due to direct sunlight or great amount of sunlight, this region gets heated up. When this region gets heated up, the air in its vicinity starts rising upwards. It is a general rule that whenever the air around a region is subjected to heat, this transforms into a vertical movement of air. Now this air is moving upwards. We have the tropopause. Tropopause, it demarcates the end of the troposphere and the beginning of the stratosphere. So when these winds hit the troposphere, they are not able to penetrate beyond the troposphere. That is why these winds will diverge. And after a period of time, when they lose their heat, because as we go higher into the sky, there is a reduction in temperature. Therefore, these winds lose their heat. And when these winds lose their energy, they start to descend. So, and upon descension, we all know there is a low pressure belt, and wherever the winds descend, they create a high pressure system. And as we learnt in the previous class that wind always moves from high pressure to low pressure. These winds will again make their way back to this low pressure region, and again due to the excessive heat they get uplifted, and this type of a cell is formed. This is called as the circulation of air. Now this is the phenomenon that is majorly the reason for the pressure belt formation. Now the next is pressure. We saw that how heat causes the formation of winds and pressure belts. Now let us see pressure or dynamic. As I told you, winds ascend over a region, and when they lose their intensity, they began to descend downwards. When the winds descend downwards, they create a region of high pressure. Here when the winds descend and create a high pressure region, there is no role of temperature. It is purely the role of the dynamics. That is the movement of air. The dynamic movement of air causes these pressure systems. So therefore, the second most important part of pressure belts is the pressure. So how are pressure belts formed? First, due to temperatural differential. Then second one is the dynamic component of air. Now let us look at the types of pressure belts. From 10 degree north to 10 degrees south, we have the equatorial low pressure belt. Now we all know the sun is directly falling on the sun rays fall directly on the equator. Therefore, 10 degree north of the equator and 10 degrees south of the equator experiences a region of extreme heat. And thanks to this extreme heat, the wind starts moving upwards. When the wind starts moving upwards, it creates a region of low pressure. When winds are leaving that place, we find a low pressure. So this is our first belt, which is called as the equatorial low pressure belt. And I told you these winds will travel in the sky until they are met by the tropopause, which blocks them in, and therefore due to the pressure difference, these winds descend. These winds descend, causing the subtropical high pressure belts. Now, why is it high pressure? It is because the winds are descending. Wherever the winds descend, they cause high pressure belts. Wherever the land is excessively cold, we see a high pressure system. Wherever the winds are ascending, that is going upwards, we find low pressure regions. Wherever the temperature is excessive, where there is greater amount of heat, we see low pressure belts. So therefore, due to the dynamic property of air, we find two subtropical high pressure belts. See, essentially the wind that is being uplifted in the equatorial region is being trapped by the tropopause and is descending. It descends over 35 degree north to 23 degree, 23 degree south to 35 degree south. In these regions, the wind will descend, causing the subtropical high pressure belt. So therefore, there are two subtropical high pressure belts, one equatorial low pressure belt. Now, upon descending in the subtropical regions, the wind, these winds will again be attracted to low pressure regions, which is the biggest lower pressure region that we see is in the equatorial zone. So upon descending in the subtropical high, the winds will make their way towards the equatorial low. Now, why aren't the winds straight? Why is there a deflection in the winds? It is thanks to the Coriolis force that dictates that any fast moving object in the northern hemisphere will deflect towards the right. So therefore, upon the effect of Coriolis force, these type of winds are created. These are popularly called as your easterlies. Now, the same thing happens in the southern hemisphere. When the winds descend upon the subtropical high pressure belt, they move towards the closest low pressure region. And here it is a rule that the winds will be deflected to the left side. Again, according to the Coriolis force, any fast moving object in the southern hemisphere will always deflect towards the left. Since the direction of winds is from subtropical to equatorial low, the Coriolis force will act in this manner, bending the winds leftwards. Now these are your easterlies. These are easterlies, these are westerlies, because okay. Next we have the subpolar low pressure belt. What happens in these regions is, we know that the poles are extremely cold because they rarely get the direct sunlight from the sun. Therefore, these polar regions are excessively cold. Therefore, in these polar regions, you see a system of high pressure. As I told you, wherever the land is very cold, wherever the region is very cold, we will see a high pressure system developing. Therefore, these two extremes, the Arctic, the northern pole and the southern pole, are in a state of complete high pressure system thanks to the cool temperature. Now, when we come below, when we make our way towards the equator, here there is a sudden rise in the temperature. This region compared to the poles is much warmer than the poles. Therefore, whenever there is heat, we see that the air always ascends upwards. Therefore, another low pressure region is being created here. Now, the winds that come from the equator not only come back to the equatorial low, they also travel to the subpolar low. The winds moving, see, here we have a region of low pressure, here high pressure, here there is low pressure, here again there is low pressure, and the general rule states that wind will always move from high pressure to low pressure. Therefore, this system of winds which are called westerlies is formed. This deflection is again because of the Coriolis force. So these are your easterlies and the westerlies. Now next, the wind, since there is a great upliftment of air in the subpolar low, that is 66.5 degree north to 45.5 degree respectively in north and south. Therefore, this region of low pressure attracts winds from the polar high. That means they attract winds from the poles and also the subtropical high. And these winds again get uplifted and they make their way back to the poles. So the winds getting uplifted here and going back to the pole, we call it as the polar cell. Whereas the wind system that we see from equator to the subtropicals, high pressure belts are called your Hadley cell. Now these are the important pressure belts of the world, which is the equatorial low, which is thermally induced. It is created thanks to the effects of the sunlight because of the temperature of the sun. So again we have two subtropical high pressure belts which are dynamically induced. That it means they are formed due to the dynamics of air. Again we have the subpolar low pressure belt, which is again due to the temperature constant, the difference of the temperature between the poles and the subpolar region. So this again, these subpolar low and tropical low, equatorial low are created thermally. And this polar high, since the region is extremely cold, therefore the high pressure system which is built here is also a thermal belt. Therefore, these pressure belts can be classified into two major categories, which is the thermally induced and the dynamically induced. So now this pressure system, it is a constant on the world. That means there is no seasonal change. These winds are present throughout the year. There is no change in them, but there is a slight movement upwards and downwards. These belts tend to shift upward and downward because of the influence of the sun. We know when north has summers, the sun's rays are directly on the 23.5 degree north. Since this region becomes extra hot compared to the equator, the equatorial low pressure belt will shift upwards. In the same way, when there is summer in the south, the entire belt will shift downwards. Therefore, the polar belts, though they are omnipresent, they tend to shift aligning with the pattern of the sun. And it is these pressure belts that dictate the climatic conditions of an area, and they are also responsible for the rainfall pattern. It is a rule that whenever the air ascends, the air carries the moisture upwards and causes a rainfall. Wherever the winds descend, downwards. We see that there is no formation of clouds, therefore there is no rainfall, which is why though the Arabian Peninsula is quite hot, though the African Saharan part is having high temperatures, still there is no rainfall because of this subtropical high pressure belt where the winds began to descend. Therefore, we see the Thar Desert, the Arabian Desert and the African Desert. These deserts are aligned in a straight manner due to this subtropical high. Thank you.